Today we're going to speak about probability of compound events. A union or intersection of two events is called a compound event. So a compound event is when we have a union or intersection of two events. It has to be two events, compound. If no outcomes are in the intersection of the two events, then those two events are mutually exclusive. Mutually exclusive means that in the intersection part, there is nothing, no outcomes, there is zero, there is nothing, there is void. Okay. For example, a standard six-sided number cube is rolled. What is the probability that it is a 4 or a prime number? So event A is having a 4. Event B is having a prime number. How many prime numbers do I have on my six-sided cube? I have 2, 3, and 5. Those are the prime numbers I have on my six-sided cube. How many other numbers? 4. He's asking for rolling a 4. So the 4 is another event. So event A is 4 happening. Event B, 2, 3, or 5. What is the probability of having A or B? The probability of having event A is 1 over 6. The event of having B is 3 over 6. Then the total of having both of them, A or B, I'm going to have 4 over 6, which is 2 over 3, which is 0.66. This is when they are mutually exclusive. What does mutually exclusive mean? There is no intersection. In the intersection part, there is nothing. What is the probability of having an even number or a prime number? Still with the same example we have, which is the cube that has 6 sides with 6 numbers. What is the probability of having an even number or a prime number? So having an even number is my A. How many even numbers do I have on my six-sided die? I have 2, 4, and 6. How many prime numbers? I have 2, 3, and 5. So event A is 2, 4, and 6. Event B is 2, 3, and 5. So bear in mind that the 2 is in both of them. This intersection part is not void, has a number in it, which means that it is not, those two events are not mutually exclusive. That's why we're going to use a different rule. Probability A or B means probability A plus probability B minus the part in the middle. Why? Because if I say that probability A is 3 over 6, probability B is 3 over 6, that means I'm counting the 2 twice. Once with the A and then again with the B. So I don't want that to happen. I want only, because the real fact is only having 5 of those numbers and not 6. Can you count them together? 1, 2, 3, 4, 5. So, but if I add 3 over 6 plus 3 over 6, I'll get 6 over 6, which is not the case. So how can I solve this problem? I'm going to solve it by putting minus the part in between, the part that is mutual, which is 1 over 6. So it goes back to having 5 over 6. So again, what am I going to do? I'm going to say that probability A plus probability B minus the part in between, which is probability A and B, the part in the intersection. Probability of compound events. If the compound events are normal, they are not mutually exclusive, then I'm going to put probability A plus probability B minus probability A and B. If they are mutually exclusive, which means that if I don't have anything in between in the intersection part, then I'm going to have probability A plus probability B with nothing to be subtracted, because already there is nothing that I can subtract. Now, we have the event A dash, which is called the complement of event A. It consists of all outcomes that are not in A. For example, if A is all the even numbers on a six-sided numbered cube, A dash will be all the odd numbers on the six-sided number cube. The rest, the ones that are not listed in A, are to be listed in A dash. Probability of the complement of an event, probability P A dash, is equal to 1 minus P A. For example, A standard deck of 52 playing cards. If a card is drawn at random, find the probability of not having a king. So I want the probability of not having the king. What is the probability of having the king? Let's start with the probability of having a king. Probability of having a king is 4. We only have 4 kings in the 52 paper cards. So it is 4 over 52. That is the probability of having a king. I don't want having a king. I want PA dash, which is not having a king. So what am I going to do? I'm going to have 1 minus 4 over 52. 1 minus 4 over 52, which is 48 over 52, which is 12 over 3, and the answer is 0.923. So the difference between A and A dash is the rest of the 1 minus PA. So, because we know that the probability altogether, added all together, summed all together would give me 1, then if I have one of them as PA, the rest will be 1 minus PA. Okay, clear? If we have PA dash, is going to be 1 minus PA.